Have you ever met someone who is the same age as you but seems so much more energetic and youthful? Or maybe someone younger who already seems tired and worn out? It's a common experience, and it highlights a fascinating idea: our chronological age. The number of years we've been alive doesn't tell the whole story. This is where the concept of biological age comes in, and scientists have found an incredible way to measure it using something called an epigenetic clock. So what exactly is biological age? Think of it as your body's true age. It reflects the health of your cells, tissues, and organs, which are shaped by everything from your diet and exercise habits to stress levels and environmental exposures. While two people might both be 40 years old, one could have the biological age of a 35-year-old, while the other might be closer to 50. It's a dynamic measure that tells us how well our bodies are actually holding up. To understand how scientists measure this, we need to talk about epigenetics. Imagine your DNA is a massive instruction manual for your body. Epigenetics is like a series of highlighters and sticky notes that tell your cells which instructions to read and which to ignore. These epigenetic marks don't change the DNA code itself, but they control which genes are turned on or off. One of the most important of these marks is called DNA methylation. As we get older, the patterns of these methylation marks change in a predictable way. Scientists discovered they could create an epigenetic clock by analyzing these specific patterns across your DNA. They take a sample, usually blood or saliva, and measure the methylation levels at hundreds of specific sites. Based on this data, they can calculate a remarkably accurate estimate of your biological age. If your biological age is higher than your actual age, it might suggest accelerated aging. If it's lower, you might be aging more slowly. Why do these patterns even change? Well, our bodies are constantly responding to the world around us. Things like what we eat, how much we move, our stress levels, and even pollution can influence these epigenetic marks. Over a lifetime, these changes accumulate, creating a unique molecular signature of our personal aging journey. It's like a logbook written directly onto our DNA. This technology isn't just a fun novelty. It has huge potential for medicine. Researchers have found that a higher biological age is linked to an increased risk for many age-related conditions, like heart disease, certain cancers, and even Alzheimer's. By identifying people with accelerated aging, doctors might one day be able to intervene earlier, long before symptoms even appear. This opens the door to truly personalized medicine, where health advice isn't just based on your chronological age, but on your unique biological profile. This all leads to the big question: can we change our biological age? Can we slow it down or even turn back the clock? The research is still young, but the early signs are promising. Studies suggest that positive lifestyle changes like eating a healthier diet, getting regular exercise, managing stress, and prioritizing sleep can indeed influence our epigenetic patterns for the better. This means we might have more control over our aging process than we once thought. Of course, the science isn't perfect yet. Different epigenetic clocks can sometimes give slightly different results, and researchers are still working to refine them and understand all the nuances. But what's clear is that these clocks are revolutionizing how we think about aging. We're moving beyond simply counting birthdays to understanding the deep molecular processes that define our health. As this science continues to develop, measuring our biological age could become a standard part of staying healthy for as long as possible. Thanks for watching. If you found this fascinating, be sure to like this video and subscribe for more insights into the science of health and aging.